In the past, I have explained a couple different ways to solve different distance rate time problems. I've said whenever we are dealing with a same distance, you can use the equation RT equals RT. Distance for one vehicle equals distance for the other vehicle. I've also said that we can watch out for a total distance type of problem, where we say the distance for one vehicle plus the distance for another vehicle adds up to a total distance d. We've also seen distance rate time problems where we're dealing with wind current or wind speed or current of a river, and what we do is we say distance is equal to rate times time for two different vehicles. We set up two simultaneous equations where one of them is going to be the speed of the vehicle plus the wind, where you get an actual boost from a wind at your tail, and then we're going to have the other where the wind is working against you and you have an R minus W times T. So we've seen that in this course already. What I'd like to take a look at this time now is to focus on the same time and the total time pattern in these next couple of problems. Now, if distance is equal to rate times time, as you well know, you can divide by r on each side and see that time is equal to d over r. So whenever I have a same time pattern, I say d over r, time for one vehicle or one journey, is equal to d over r for another journey. Now when I have a total time, I go d over r plus d over r is equal to a total time t. Now let's use these bottom two patterns in this next problem. And as you read it, you'll see in the same time. That tells you we want to go with the d over r equals d over r approach. And what I like to do is I like to label that this left side is going to be for Brooke and the right side fraction is going to be for Anna, and then I start substituting in my values. Brooke walks 2 kilometers an hour slower, so r will be in my Anna fraction and r minus 2 will be in the Brooke fraction. Brooke can walk 12 kilometers, that's a distance, in the same time that Anna can walk 18. Notice how easy it was to come up with this equation, and it says we're trying to find both of their speeds at the end. So we're going to be looking for both r and r minus 2 when we solve this. Now, we're going to just solve this easily by multiplying through by r times r minus 2, which is the least common denominator. Or you can think of this as cross multiplication. On the left, after the r minus 2's cancel, you're going to have 12r, and on the right, after the r's cancel, you'll have 18 times r minus 2. Doing the distribution on the right-hand side leaves us with 12r is equal to 18r minus 36. Subtracting the 18r on each side gives us negative 6r equals negative 36, and r turns out to equal 6 kilometers per hour. Now up above we put r in the Anna fraction, so this is actually going to be Anna's speed. Whereas r minus 2, which I need to show you here, is going to be 4 kilometers per hour, which is going to be Brooke's speed. This next problem can be a little bit tricky because we see that it's 60 miles to an island and 60 miles back again, and when you try to set this up as a same distance type of problem, you just don't have enough information to solve the problem. So instead I want to focus on this instead as a total time, because it says the total time of the trip was 9 hours. So I'm going to go d over r plus d over r is equal to a total time t. And that total time t is going to be 9 hours. We know that the distance in both directions is going to be 60 miles. And you know that the return trip, which I'll put second, is going to be 3 miles an hour slower. So we're going to have r and r minus 3. And the first fraction there is going to be to the island. The second one will be coming home from the island. We're going to solve this by multiplying through by the least common multiple, r times r minus 3, least common multiple of the denominators. And this is going to give us 60 times r minus 3 plus 60r is equal to 9 times r minus 3. And doing the distribution on the left and the right is going to give us 60r minus 180 plus 60r is equal to 9r squared minus 27r. Okay, we see with that 9r squared that this is a quadratic equation, so we want to set it equal to 0. And I'm going to slide everything to the left a little bit. There's the 9r squared. 60 plus 60 is 120, so we have 120r on the left that needs to be subtracted off. Subtract it on the right and have minus 147r. And adding 180 to both sides gives us a plus 180 on the right side. Now we want to factor the right, and I notice that I can divide out a 3, leaving 3r squared minus 49r plus 60. And we can really ignore this 3 out front, but I'll keep it here for the moment. And it turns out we're going to have 3r times 1r, and it turns out also that we're going to have 15 times 4. A minus 4 and a minus 15. That gives me my minus 45 on the outer and minus 4 in the middle, making that minus 49. And it turns out then that r is equal to 4/3 miles per hour, or r is equal to 15 miles per hour. It looks like we have two solutions here. But when we go back to the problem, we're not just looking for r, we're looking for r minus 3 also. And if you try to subtract 3 away from 4/3, you're going to end up getting a negative value, which will not work. So 4/3 is not a valid solution here. R minus 3 is going to be 12 miles per hour, which will be the speed for the return trip. And so in this problem, the going to the island is at 50 miles an hour, and returning from the island is done at 12 miles per hour.